Dawson Products, through the Chronotron brand line in the welding department, has an incredible line of brazing products. This blue rod here, we call the 43F. It's a silver brazing rod, and it is one of the most popular general brazing rods and the most versatile brazing rods in shops today. So before we get started, I want to read you the technical data sheet so you understand exactly about what this thing will do. It's an incredible product. We call it the Maintenance Man's Silver Brazing Alloy, specially formulated for general purpose maintenance and repair applications. It's got this blue flux coating. Some of the advantages: it's got high ductility. It allows joint metals to expand or contract without weakening the joint, which is important. Excellent for all types of joints. It does lap, butt, T-joints, sleeve joints, any type. Now, what's incredible about this, it's got the lowest temperature bonding of any high-strength silver at 1100 degrees, whereas most of them melt at 1300. The metal has to get red. Now, it joins any combination of metals, including stainless steel, copper, brass, Monel, most other alloys. It won't do aluminum or light metal. It's got thin flowing ability into the tightest joints, so it's got incredible capillary action, which is important to get a job done right. The tensile strength is 88,000 psi, which is stronger than a stainless steel electrode or MIG wire. The temperature application is 1100 degrees. Because it's so low, you can use a MAP gas torch, which is about a 3500 degree flame, compared to propane, which is 2600, but use MAP gas. Imagine the portability using a MAP gas torch out in a plant. Some of the applications are instrument and electrical appliances, tool and die repairs, hot water tanks and piping, carbide tool tipping, metal furniture and light gauge assemblies, bronze and brass castings, and it does valve and lab apparatus. There's also an orange version called the 40F for food and beverage equipment and laboratory equipment. It doesn't have cadmium or lead in it. Let me show you how it works. First of all, if you noticed, I had it in this water. It's got a moisture-resistant coating. An incredible coating, so you don't have to worry about it going bad over time. Check the flexibility of this coating, this flux out. I can bend this around. It comes in an 18-inch length, so it's not going to go bad. And it's got an incredible flux coating that's super active flux that'll clean and do a lot for you. So I've had this in the water quite a while. We'll go ahead and use it. I'll put it back for now. This is the type of flame you need. You want to have a good tip, medium-sized tip or a smaller tip. The gas pressures you want on the acetylene is 5 to 10, and the gas pressure on the oxygen is the same, 5 to 10, okay? So let's go ahead and strike the torch, and I'll show you what kind of flame you need. Well, you need on a flame, you don't need a lot because it's 1100 degrees. Of course, propane, it'll work on MAP gas as well, like I mentioned. So I'm going to bring this down, and what you have here is a neutral flame where both cones meet together, but I am going to soften it a little bit by adding acetylene. We call that a soft carburizing flame. And if you can hear the flame, you're probably set too high. Let's move it down. And what you want is a double cone with a pencil point. That pencil point is going to help you out. It's going to direct the flame. You want to put the end of that pencil point on the outer cone on your workpiece. All right? So let's pull the rod out of the water, and let's heat up the base metal. What you've got here is a piece of brass and a piece of stainless. As you know, it's more difficult to braze two different metals together than it is the same. This, as I mentioned earlier when I read that, it'll do all ferrous and non-ferrous metals. So you can do bronze, brass, copper, stainless, and any type of steel in any combination. I'm going to go ahead and heat this up by putting my pencil point right in the corner. Let's bring it up close to temperature. I can start to see the metal turn red. So actually, I don't have a temperature crayon or any type of device to figure out where my temperature is, but you have a flux coating that's going to be a great temperature indicator. Also, it's going to go in and clean the area of contaminants. So let's roll some flux in off the 43F. It's flux coated. It's a clear liquid. Right now it's not quite going into the joint, but as I put more heat on her, it slips right to the joint. It's clearing out any contamination in the way. Let's put a little bit on this end. There. So now I'm rolling the flame around and I can see the clear liquid go right into the joint, and that's telling me it's ready to accept the alloy right behind it. Now, you only need a small drop to successfully do a joint like this. So this 18-inch rod will last quite a while. Let's go ahead and put a drop in here, and I want you to see the capillary action. Capillary action is the ability for it to flow through a joint. Now you can see I just have a drop in the corner. Let's put the flame in front of it and pull it. Check out that capillary action. Done. We just shot it through that side of the joint. Let me let you look at that again. You do it on this side. There. Actually, it shot right through the rest of the joint. Now, a lot of times you're going to have a lap joint, or you got to pull it through a sleeve, and you've got to pull it quite a ways. This thing will fly. I'm just going to tap a little bit of a flame on the back, and it shot right underneath, just like that. So as you can see, I only used 1/4 of an inch or less of this product and put a drop or two on a joint like this and brazed it. So let's turn off the torch. One thing you don't want to do with a typical brazed joint is to squelch it really fast. Okay, but I tell you what we'll do. For the sake of time, I'm going to do that. I'm going to douse it in water. If you remember me reading the technical data sheet, I said it's got high elongation factor, so it takes vibration and things. Sometimes you're going to have an application, a chiller or something that heats up and cools down quite a lot. You need an alloy that's strong, this giving you 88,000 psi, but you need one flexible as well. So I just doused it in water. Normally it would weaken a joint, but this one can handle it. Well, let's see what it takes to knock this brass off from this stainless steel. As you can see, I took a 3-pound hammer to it and it didn't move. It didn't come out on the corners or ends. It didn't break on the backside. That's some incredible force. So basically what you can conclude from this is a reliable alloy. It's going to go a long way. It's going to be easy to apply. And it's going to work in a dirty environment when you get that flux to remove those contaminants. It's a great product, and it would be a great addition to your shop.